Welcome to Learning Gateway. Today we are going to start the new category of analytical reasoning, which is known as networking. Basically, in networking, we have to connect various data points with one another using the given option. The connection between these data points could be from one side or both sides. Simply, we can say that if a road moves from one side, that is known as one-way road, and there could be two-way or two-side roads as well. And then it is asked that to move an object or a car from one point to another point using minimum time or minimum points in a type of moving from one place to another place. In these kind of problem, you have to be careful about the single path or a single road and double road. Mostly that is a tricky portion of such a problem. So you have to be careful about that. Okay, let's start our today case and make it more clear. The case we have today that there are 7 towns, which is T, U, V, W, X, Y and Z. And all the existing roads between these towns are two-sided, or even the projected roads as well. And we have also given information about the link between these towns, which is that road 1 goes from T to V via U, and second information is that road 2 goes from U directly to W, and the third one is that a triangle road goes between X and Y and Z, and then from Z to X. So let's draw that link between these towns, and then we will move toward the question we have. You can see that here I draw the link mentioned between these 7 towns, which is that road 1 goes from T to V via U. That is road 1 from T to V via U. Mean first it goes toward U, and then from U it moves toward V. The second road is directly from U to W. And the third road is a triangle between Y, X and Z. But before moving toward the question, you can see above in the mentioned information that all roads are straight and U is from the same distance from T, V, W, as Y is from the same distance X and Z. But they didn't mention the distance between Z and X, this road. As I have thought earlier that before moving, when you convert the information to symbolic form, first of all, you have to look for the implied information. In this case, this is the implied information that they did not mention about the distance between Z and X. Now let's move toward the first question we have, that is, which of the following is a town from which exactly 2 other towns can be reached by the road? Let me tell you one thing. They mentioned that exactly 2 roads, mean not more than 2, not less than 2. Now we have to look around that which town is a town from where 2 other can be reached using road. For that purpose, we have given option A, T. So from T, there is only one single road. Option B is U. From U, there are 3 roads. We can reach towards, or we can reach to 3 towns at a time. Option C is V. From here, we can reach to 1 town only directly. And then W and D. Next option is W. From where we can also reach to 3 towns. And the last option is X. So you can see from X we can reach only to 2 towns, which is Y and Z. So this is our correct option. The second question about this network is that it is possible that the distance by the road from X to Y is unequal to the distance by the road from. So over here in a start, I have told you that there is only one road about which that is not mentioned, or the distance of this road between Z and X is not mentioned. and all the other roads are on equal distance from one town to another town. So the option we have over here, that is option D, that X and Z. So their distance could be unequal to the distance of X and Y. Now the third question we have, that which of the following is a pair of town connected by the road, they have no stretch of road in common. Option A is T and U. T and U, they are connected only by one road. The second option is U and V. U and V, the same case is here. Third option is that V and W. These two are also connected only by one route, from over here from T to U and from U to W. The fourth option is W and X, as we can see that there is no connection between these two. So that is not possible. And the last option is that X and Y. X and Y. You can see that X is connected with Y through two different routes, which is one route is from X to Z and from Z to Y, and the second route is directly from X to Y. No, this is our correct option. The fourth question is that if a projected road from T to Y were built, then the shortest distance by the road from W to X would be the same as shortest distance from Z to which town? Let's make a projected route first between T and Y. Over here, we made a projected route between T and Y. And right now, let's move from W to X. If we move from W to X, so the possible or the shortest way is first to U, then T, then Y, and then X. So you can see that moving from W to X, we touch 3 towns on the way, and the fourth one is X. The first one is U, second one is T, third one is Y, and the fourth one is our destination. Now we have to look down for a town which could be on the same distance from Z as X is from W. The first given option is option T. So if we move from Z to T, so there is only one town in between. So that is not equal distance as the distance between W and X. The second option is U, from Z to U. So if we move from Z to U, first, second, and the third one is the destination. But that should be the fourth one, or the destination should be the fourth one. The third option, or option C, we have, that is V, from Z to V. So let's start from Z to V. First, second, third, and fourth. The fourth one is our destination. Right now, this is the same distance as we have from W to X. Okay, let's move to the last question about this networking problem, which is if two roads were built, one from T to Y and another one from V to Z. As we have already drawn from T to Y, and the second one is from V to Z, or from Z to V. Now it is stated that the following would be a complete list of towns that a traveler going from U to X except. Mean we have to find out the incorrect or the wrong option. Option A we have, that is T and Y. Moving from U to X. From U to X, that person could use T, Y, and then X. So that is possible. Option B is, that is T and Z. So from U, if we move first T, and then we have to touch the Y, or the town Y, we cannot directly go to Z. So this option is not correct. Okay, this was all about our today's lecture, which was about the networking problem, and all the road in today's case we have, they were two-sided or two-way roads. But in next lecture we will have a single or one-way road as well as two-way, and I will teach you how to tackle with that problem. But before closing this lecture, let me give you an assignment relevant to our today's lecture. The problem you have to solve that there is a long airport where a loop bus is traveling from terminal A to terminal B and then long-term parking. In terminal A, there are 4 stops, which is A1, A2, A3, A4. And in terminal B, there are 3 stops. And then bus move to long-term parking. Moreover, there are 2 monorail in the airport as well, which is moving from A3 to long-term parking, and the second one is moving backward and forth from B2 to long-term parking. Using this information, first you have to draw a complete map of that airport, and then you have to answer the question relevant to that problem. That was all for today.